NEC 210.8b4 mandates that outdoor GFCI receptacles must be supplied by a dedicated branch circuit. The logic behind this requirement centers on enhanced safety, reduced trip nuisances, easier troubleshooting, and compliance with industry best practices. Firstly, enhanced safety is a primary concern. By isolating the GFCI receptacle on its own circuit, any fault in the receptacle or its connected equipment will not affect other outlets or appliances on the same circuit. This prevents a fault in one outdoor device from potentially causing a hazard or power outage in other areas of the building. Secondly, reduced trip nuisances are minimized. Multiple devices drawing power from the same circuit can increase the likelihood of nuisance trips, reducing the effectiveness of the GFCI protection. Dedicating the circuit solely to the GFCI receptacle minimizes this risk because there are no other devices contributing to potential ground faults or overloads that could trigger the GFCI. Thirdly, easier troubleshooting is facilitated. If a fault occurs, it becomes much easier to isolate the problem to the GFCI receptacle and its protected equipment by having it on its own circuit. Without other devices on the circuit, the source of the fault can be quickly identified and addressed, saving time and effort in the troubleshooting process. Finally, compliance with industry best practices ensures that the electrical installation aligns with widely accepted standards for enhancing safety and reliability of outdoor GFCI protection. The dedicated circuit requirement is recognized as a fundamental aspect of ensuring the GFCI functions effectively and provides the intended level of protection. Let's delve deeper into the technical aspects. A GFCI, or ground fault circuit interrupter, is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing into and out of the circuit. If there is an imbalance, indicating that current is leaking to ground, the GFCI quickly trips the circuit, cutting off power and preventing a potentially dangerous shock. Outdoor environments present unique challenges for electrical safety. Moisture, exposure to the elements, and the potential for damage from tools or equipment all increase the risk of ground faults. Therefore, it is crucial to ensure that outdoor receptacles are properly protected by GFCIs and that the GFCIs function reliably. The dedicated circuit requirement helps to ensure this reliability. When a GFCI receptacle is on a shared circuit with other devices, there is a greater chance of nuisance tripping. This can occur due to the cumulative effect of small ground currents from multiple devices or due to voltage fluctuations caused by other loads in the circuit. Nuisance tripping can be frustrating and can lead to the GFCI being bypassed or disabled, which defeats its purpose. By dedicating a circuit to the GFCI receptacle, these potential sources of nuisance tripping are eliminated, and the GFCI is more likely to function reliably when a true ground fault occurs. Moreover, a dedicated circuit provides a more stable and predictable voltage supply to the GFCI receptacle. This is important because GFCIs are sensitive to voltage variations, and fluctuations in voltage can affect their performance. A dedicated circuit ensures that the GFCI receives a consistent voltage, which helps to ensure that it operates correctly and provides the intended level of protection. In addition to the benefits mentioned above, a dedicated circuit can also simplify the process of testing and maintaining the GFCI receptacle. With no other devices on the circuit, it is easier to verify that the GFCI is functioning properly and that it is providing adequate protection. Regular testing of GFCIs is recommended to ensure that they are working correctly, and a dedicated circuit makes this process more straightforward. Furthermore, the dedicated circuit requirement aligns with the general principle of electrical safety, which is to isolate circuits and minimize the potential for faults to spread. By isolating the GFCI receptacle on its own circuit, any fault that occurs is contained within that circuit, preventing it from affecting other parts of the electrical system. This helps to reduce the overall risk of electrical hazards and to improve the safety of the electrical installation. When installing a dedicated circuit for an outdoor GFCI receptacle, it is important to follow all applicable electrical codes and regulations. This includes using the correct wire size, installing the appropriate overcurrent protection, and properly grounding the circuit. It is also important to ensure that the GFCI receptacle is rated for outdoor use and that it is installed in a weatherproof enclosure. The wire size for the dedicated circuit should be selected based on the ampacity of the circuit and the length of the wire run. The ampacity of the circuit is determined by the size of the overcurrent protection device, which is typically a circuit breaker or a fuse. The length of the wire run is the distance from the panel board to the GFCI receptacle. The longer the wire run, the larger the wire size that is required to prevent excessive voltage drop. The overcurrent protection device should be sized to protect the wire from overload and short circuit. The size of the overcurrent protection device should not exceed the ampacity of the wire. It is also important to ensure that the overcurrent protection device is properly rated for the application. For example, if the circuit is supplying a motor, the overcurrent protection device should be rated for motor starting currents. Proper grounding is essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, which allows the overcurrent protection device to trip and clear the fault. The grounding system should be installed in accordance with the applicable electrical codes and regulations. The GFCI receptacle should be rated for outdoor use and should be installed in a weatherproof enclosure. This will protect the receptacle from moisture, dirt, and other environmental factors that could damage it. The weatherproof enclosure should be properly sealed to prevent water from entering. In addition to the above considerations, it is also important to follow the manufacturer's instructions for installing the GFCI receptacle. The manufacturer's instructions will provide specific information about the installation requirements for the particular receptacle. By following all applicable electrical codes and regulations, as well as the manufacturer's instructions, you can ensure that the dedicated circuit for the outdoor GFCI receptacle is installed safely and correctly. This will help to protect people from electrical shock and to improve the reliability of the electrical system. In summary, the requirement for dedicated circuits for outdoor GFCI receptacles is based on sound engineering principles and is intended to enhance electrical safety and reliability. By isolating the GFCI receptacle on its own circuit, you can reduce the risk of nuisance tripping, simplify troubleshooting, and improve the overall performance of the GFCI protection. Compliance with this requirement is essential for ensuring the safety of outdoor electrical installations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. The NEC is not law, but it is widely adopted by state and local governments and is used as the basis for electrical inspections. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for certain types of electrical installations, such as outdoor receptacles. The NEC is a valuable resource for electricians, electrical engineers, and anyone else who is involved in electrical work. It provides detailed guidance on how to install electrical systems safely and correctly. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops and publishes codes and standards for fire safety and electrical safety. In addition to the NEC, the NFPA also publishes a wide range of other codes and standards related to fire protection, building construction, and life safety. The NFPA is a leading source of information on fire safety and electrical safety. The dedicated circuit for an outdoor GFCI receptacle typically consists of a 120 volts, 15 amps or 20 amps circuit. The specific amperage depends on the anticipated load and local codes. The wiring typically involves 14/2 with ground or 12/2 with ground cable depending on the breaker size. The ground wire is crucial for safety and should be properly connected to the grounding system. The installation should also include a weatherproof box and cover for the GFCI receptacle, protecting it from the elements. Remember to always de-energize the circuit before working on any electrical wiring to prevent electrical shock. Always consult with a qualified electrician if you are unsure about any aspect of the installation. Proper installation and adherence to the NEC are crucial for ensuring the safety and reliability of the electrical system. Brown fault circuit interrupters are designed to trip when they detect a difference of 5 mA or more between the current flowing into and out of a circuit. This small difference in current indicates that current is leaking to ground, which could pose a shock hazard. The GFCI trips very quickly, typically within 25 milliseconds, to minimize the duration of the shock. This rapid response is crucial for preventing serious injury or death. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. These areas are typically wet or damp, which increases the conductivity of electricity and makes it more likely for a person to come into contact with a live electrical wire. GFCIs are an essential safety device for protecting people from electrical shock. They are relatively inexpensive and easy to install, and they can save lives. It is important to test GFCIs regularly to ensure that they are functioning properly. The test button on the GFCI receptacle simulates a ground fault, which should cause the GFCI to trip. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to GFCIs, there are other types of safety devices that can be used to protect people from electrical shock. These include arc fault circuit interrupters, RFCIs, and surge protectors. RFCIs are designed to protect against arc faults, which are a type of electrical fault that can cause fires. Surge protectors are designed to protect against voltage surges, which can damage electronic equipment. These devices can be used in conjunction with GFCIs to provide comprehensive electrical safety. When working with electricity, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing circuits before working on them. It is also important to be aware of the potential hazards of electricity and to take steps to avoid them. Electricity can be dangerous, but it can also be used safely if proper precautions are taken. The NEC provides detailed guidance on how to work with electricity safely. It is important to follow the NEC requirements to ensure that electrical installations are safe and reliable. The NEC is a valuable resource for electricians, electrical engineers, and anyone else who is involved in electrical work. It provides the information needed to install electrical systems safely and correctly. Proper electrical installation and maintenance are essential for preventing electrical hazards and ensuring the safety of people and property. The dedicated circuit requirement for outdoor GFCI receptacles is just one example of how the NEC promotes electrical safety. By following the NEC requirements, you can help to create a safer electrical environment.